Hello, in this video I'm going to be going over single replacement reactions, also known as single displacement, either or. And how we do this is we use an activity series. This activity series you will have a copy of to use on your test. I got nice little laminated ones for you to use. And what it is a series of showing strength of ions. So we have various metals, and the higher up on this column, the stronger it is. So lithium is the strongest, and then we have the jewelry elements. Silver, platinum, and gold are the weakest. So do you have to memorize this for my class? No, you will have this chart, but you do need to know how to use it. And there are two columns. This non-metal column is for if you have halogen versus halogen, which one's stronger? Fluorine at the top is strongest, and iodine and sulfur at the bottom are the weakest. So, doing a problem of predicting the product. Alright, we got lithium versus barium. If it turns out that barium is stronger than lithium, then you don't have to do anything but write NR, which stands for no reaction. So those are nice because they're pretty easy. Just got to write NR. So we've got lithium versus barium, and the only way to know which one's stronger is by looking at the activity series. Lithium is the highest one up, so right away I don't even have to try to look for barium, although it is right there. Lithium is higher, so therefore it is stronger. It's going to end with the anion. So it's going to boot out barium, and it may be helpful, since we need to balance this equation potentially, to just write it out. So lithium, the one by itself is always going to be a solid if it's a metal. If it's a halogen, most likely it's going to be a gas, or possibly, well, bromine a liquid and iodine a solid. We have BaCl. Alright, Cl, I remember, is a halogen. It's a 1 minus, and Ba is in column 2 of the periodic table. It's a 2 plus. Crisscross it, and it's BaCl2. And we're saying that lithium is booting out barium. I don't have to write the charges, and I don't have to write the arrow. I'm just showing that for demonstration purposes. So lithium is going to be with chlorine, and barium is going to be all by itself. And if it's a metal, that would mean it's a solid. And why am I not putting that a 2 there? Well, because it might not be balanced or a 0 charge if I do that. So I need to double check to make sure if I do need a 2 after that Cl. Cl we said is minus 1. Lithium is in column 1, so it's a plus 1 charge. Plus 1 minus 1 is 0. It's balanced that way, so we just leave it as LiCl. So really there's 3 total steps. First step, predict a product by looking at the activity series to see what's going to happen if there's no reaction or if a reaction occurs. Second step, make sure our molecules have an overall 0 charge. And in the third step, we need to satisfy the law of conservation of mass, which states that matter cannot be created nor destroyed. So in this case, we have 2 chlorines and 1 chlorine. We have to add a coefficient to rectify that. But then that gives us 2 lithiums. We only have 1, so we need to add a coefficient there. Barium, 1 barium, 1 barium. It is balanced, and we just predicted the products of this single replacement reaction. Alright, let's do another problem, just so we can get some more practice. We have copper plus sodium oxide. Before we do anything, this might be a no reaction one, so we don't want to do any extra work, so let's see if it reacts or not. So copper versus sodium. We have copper right down there, and sodium is somewhere in here, all the way up here. So sodium is definitely stronger because it's higher up. So sodium wins out. It's going to be with the anion, and here it already is with the anion. Copper cannot boot sodium out. It's too weak. So in that case, we're going to put no reaction. And we're done. Alright, trying another one. Let's do zinc plus lead 4 hydroxide. So remember, zinc is Zn, and lead is Pb, and hydroxide is that polyatomic ion that will be on the polyatomic ion sheet that you have for your test. But if you're a superstar, you'd know it's OH with a minus 1 charge. OH with a minus 1 charge. And lead, since it's lead 4, is plus charge. So 4 plus, 1 minus, crisscross it. You're going to need 4 OHs. And, well, let's see, zinc versus lead. We might not have even had to do that. Zinc is up here, and lead is down there, so zinc is stronger, and this reaction will occur because zinc is strong enough to boot lead out. So we have ZnOH, stronger one ends with the anion, plus Pb. And Pb is going to be a solid because it's all by itself and it's a metal. And zinc is one of those exceptions. It always has a 2 plus even though it's the transition metal. It's always 2 plus. Hydroxide always 1 minus, crisscross it to balance it. We have ZnOH2. So what we did was we predicted the product. That's step 1. Step 2, make sure our overall compounds have a 0 charge. And then step 3 is add coefficients to balance the reaction. 1 zinc, 2 hydroxides, 4 hydroxides. Since OH is found on both sides of the arrow, I can count OH as one entity. It's a lot easier that way, as opposed to counting the oxygens and hydrogens separate. So that would give me 2 times 2 is 4. That gives me 2 zinc, so I got to put a 2 right there, and that balances it. Doing one more, I want to do one that is a little bit different than the ones that we've been working on. Here we have fluorine versus sodium bromide. Normally it's metal versus metal. We only have one metal here. Bromine is a nonmetal, fluorine is a nonmetal. So writing this out, fluorine plus NaBr, bromine's -1, sodium's +1 is balanced. But F is one of the 7 diatomic elements that you have to have memorized. So whenever F is by itself, it's not F, it's F2. Alright. And now it's, a lot of people would try to figure out, is fluorine stronger than sodium? No, you don't do that. Like charges with like charges. So fluorine by itself is a -1 charge. It's just F. Bromine is a -1 charge. So it's minus charge versus minus charge. Fluorine versus bromine. We have fluorine. We have bromine. Fluorine is much stronger. It's higher up on the activity series. The stronger one wins out and will end up in the compound. So in this case, fluorine does boot bromine out. I'm going to boot it out, so it's going to be NaF plus Br. But bromine is one of the 7 diatomic elements, so it's always Br2. And it's a liquid. It's unique. There's just 2 liquids at room temperature, bromine and mercury. And then NaF -1 plus 1 is balanced. Technically, I should be writing aqueous for my compounds. So that is that we might have to balance the equation. We predicted products, step 1. Step 2, we made sure that the compounds have an overall 0 charge. Step 3 is balancing it by adding coefficients. 1 fluorine, 2 fluorines. We need a 2 there. 2 sodiums, 1 sodium, we need 2 there. 2 bromines, 2 bromines, and it's balanced. And we have just predicted the products of the single replacement reaction. I just want to go back and recap. This barium chloride here should have been aqueous. Same with this LiCl, this zinc hydroxide, and this lead 4 hydroxide should have all been aqueous. So we always have a solid and an aqueous, or in this case, a gas and an aqueous. And it may be helpful to look at the periodic table in the classroom. That's really big. It has elements that are red that stand for gas. The 2 blue ones, bromine and mercury, stand for liquid. Black stands for solid. So as single replacement reactions, it just takes a lot of practice to really nail it. And I hope you enjoyed.